onto an ice-cold frozen pole? How is sound and light energy important to our existence? And can we exist? Have you ever wondered what would happen if your tongue stuck onto an ice-cold frozen pole? How is sound and light energy important to our existence? And can we exist with one and not the other? How does gravity, electricity, and magnetism affect our natural world? How and why substances combine or separate to form other substances? Chemistry deals with a lot of things. We ask questions like, how can the car move? What is providing the forward motion? How are the wheels even able to turn? How high can a ball that was thrown move upwards? Why doesn't oil and water mix? Where does the white light on the stage come from when all I can see is different color lights? is just applying or finally using all of the tools you have accumulated throughout your education to figure out the way the world behaves. Take chances.
Good day, grade 9 learners. Welcome to today's natural sciences lesson. My name is Sianda Madala, and this lesson is proudly brought to you by the Gauteng Department of Education. Right, we are still on our term 2 and exploring the knowledge area, matter, and materials. And in today's topic, we'll be talking about chemical reactions as promised, right? So now, let's quickly look at our lesson objectives. So remember that this is what we need to achieve by the end of this lesson, right? So by the end of the lesson, we should be able to explain what a chemical reaction is, right? You should be in a position where you can tell the next person or explain to the next person what a chemical reaction is. Also, we need to be able to represent chemical equation as what? Chemical equations as models and also symbols, right? Not only that, we need to be able to explain the purpose of the subscript in a compound. Also, we should be in a position where we are able to identify the ratio in which molecules react. Also, we should be able to write out word equations for chemical reactions. Not only that, we should be able to write out balanced equations in symbol form. And all this information is found under the CAPS document on page 64. Right. Now let's look at what we have done before, right? Our pre-knowledge. So now in grade 8, we have done matter and materials under term 2 as well, right? So under matter and materials in grade 8, we discussed chemical reactions, right? So the topic of chemical reactions is not a new topic, but it has been visited and introduced in grade 8, right? Also, we've talked about atoms and elements, right? And this is an illustration of chemical reactions, right? To show that now new substances are formed from the substances that were in the reaction, right? Now, then in the same grade that we're in now under matter and materials as well, we have discussed compounds, right? Which was our previous lesson. So we've talked about the topic of compounds as well, right? So we said that compounds are formed by two or more elements that are chemically bonded in a fixed ratio, right? So here is an example that we've been talking about in the previous lesson, the example of water as a product, right? Or water as a compound. So now, let's quickly look at our baseline activity. Number 1 of our baseline activity says, copy and complete the following sentences. A, the subscript number indicates the number of an element found in the formula. Then B, the numbers in front of the compounds indicate the in which the molecules react. Then number 2, you simply need to write down the names of the compounds that contain the elements listed below. A, calcium and sulfur, then B, chlorine and sodium, right? So because it's 4 questions, I'm going to give you 4 minutes to complete this activity. Welcome back, grade 9s. Now, if you want to send in your answers, comments, or any questions regarding this lesson, our WhatsApp number is 079-578-2908. Right. Now, let's look at the solutions for this baseline activity. Number 1, copy and complete the following sentences, right? The subscript number indicates the number of atoms, right? It indicates the number of atoms of an element found in the formula. Then B, the numbers in front of the compounds indicate the ratio in which the molecules react, right? Then number 2, write down the names of the compounds that contain the elements listed below. A, calcium and sulfur. The compound is what? Calcium sulfide. Then B, chlorine and sodium. The answer is sodium chloride, right? So now, if you need some time to copy down corrections, I'm going to give you a quick minute to copy down your corrections. Then after that, we shall continue with our lesson. Welcome back again, grade 9s. Now let's continue with our lesson, right? So let's start off by highlighting the important terms that we might come across as we proceed with our lesson. Right. The first term that we have there is chemical reaction, right? And we define chemical reaction as a process that involves the rearrangement of the molecular or ionic structure of a substance. Right. Then we have reactants, right? Which is a substance that takes part in and undergoes change during a reaction. So it is a substance that takes part in and undergoes change during a reaction. Then we have products. Products now are substances that are obtained from another substance through chemical change. Then we have coefficient, right? And a coefficient or it is the number in front of the formula in the chemical equation, right? So a coefficient is the number in front of the chemical formula in a chemical equation. Then subscript. The subscript is the number that indicates the number of atoms of an element found in the formula, right? So bear in mind the differences between coefficient and subscript, right? Coefficient, it is the number in front of the formula in a chemical equation, whereas the subscript, it indicates the number of atoms of an element found in the formula, and we'll talk more about that today. Then lastly, we have balanced equation, right? This is an equation that has the same number and type of atoms on the reaction side and on the products side. Now, let's talk about today's main meal, right? Chemical reactions, right? Chemical reactions. So, in your own words, how would you define a chemical reaction, right? That's my first question to you. How would you define a chemical reaction? So, I'm going to give you a chance to write down some of your ideas, right? And the following words that I'm going to put here may help you formulate your sentences, right? So we have words such as reactants, products, bonds, rearranged atoms, molecules, and new compounds, right? So without me disappearing again, I'm going to give you slightly 30 seconds to decide which words to use to define chemical reaction, right? So let me just stand here and wait for a bit. Right. I hope that time was enough, right? So you might have different responses as well, right? Because you have words like reactants, products, bonds, rearranged atoms, molecules, and new compounds, right? So you needed to just simply define chemical reaction using these words, right? Some might say it's a reaction where reactants are changed or rearranged to form new products, right? Or chemical bonds are broken down so that you can form new bonds or to form new compounds, right? So now, in my own definition, right, a chemical reaction is a rearrangement of atoms in which one or more compounds are changed into new compounds, right? So it is a rearrangement of atoms in which one or more compounds are changed into new compounds. That's what a chemical reaction is, right? So now, bear in mind that all chemical reactions, they can be presented or represented by equations and models. So what really happens during a chemical reaction, right? Let's note this, right? New compounds are formed, right? But bear in mind and note this, right? No atoms are lost or gained, right? So during a chemical reaction, no atoms are lost and no atoms are gained, right? But they are simply rearranged, right? They are rearranged to form new compounds, right? So now let's carry on with our lesson. Representations of chemical reactions, right? So how can we represent these chemical reactions, right? So there are three ways in which we can represent chemical equations or chemical reactions, right? The first way is by word equations, right? We can simply use words to express the equation, right? Also, we can use picture equations. And the third one, we can use chemical equations or the symbols that we find from our periodic table on our elements, right? So we can use word equations, picture equations, or chemical equations, right? So let's talk firstly about word equations. How can we use these words, right? So now, we write a word equation, right? As the word says, word. We use words to formulate our equation. So for example, when hydrogen gas reacts with oxygen to form water, right? We can also write a word equation to express that chemical reaction, right? And we can do it as follows, right? As you can see, it is hydrogen in words plus oxygen in words to form water, right? This whole chemical equation is in word format, or it is in words, right? It is hydrogen plus oxygen to form water. Are we together? So now, let me just remind you from our previous lesson, right? That on the left-hand side before the arrow, right? We find what we know as reactants, right? We find what we know as reactants. Then on the right hand side after the arrow, we find what we know as products, right? So let me just juggle your minds again, right? So what are the reactants of this reaction? The above reaction in that word reaction. What are the reactants? The reactants are hydrogen and oxygen, right? The reactants are hydrogen and oxygen. And what are the products? The products are, or the product is water, right? So let's not forget that part where we put our reactions, or reactants, sorry, and our products in a chemical equation, right? So now, picture equations, right, which is the second second representation, right? So now we're going to use the same example, right, of the reaction of hydrogen reacting with oxygen to form water, right? So these picture equations, they are somehow known as submicroscopic diagrams, right? So now here is a picture equation, right? As you can see, we have molecules of hydrogen reacting with a molecule of oxygen and to form two water molecules, right? So now if you were to count the number of atoms here of hydrogen, there are four, right? There are 1, 2, 3, 4 reacting with two atoms of oxygen to form a whole what? Two molecules of water, right? 2H2O. So again, just to test your minds, right? What is the product of the above reaction, right? Product of the above reaction. And what are the reactants of the above reaction, right? So the product now, it's what? It is two water molecules, 2H2O, right? So the H2O is one water molecule. Now the 2H2O, it means that there are two water molecules, right? Then the reactants, it is what? It is four hydrogens, 2H2 plus O2, right? So these are the reactants of this chemical reaction, and this is the product of this chemical reaction, right? So now let's dwell more into this lesson. Chemical equations. Now, chemical equations can be used as well to represent what? Chemical reactions, right? So now when we represent a chemical reaction in terms of chemical symbols, that's when we say what? It is a chemical equation, right? We represent it in terms of what? Symbols, or we use symbols to represent these equations, right? So the chemical equation for the above reaction, the reaction of hydrogen and oxygen, is as follows, right? 2H2 plus O2 to form 2H2O, right? Now, plus, note this. It's only symbols that are used here, right? Hence, we say it is a chemical reaction. We use the symbol H for hydrogen, and we use what? The symbol O for oxygen, right? Only symbols that we find on our periodic table, on our elements, right? Only them can be used in a chemical reaction, or the symbols, right? Now, we have activity 1 just to test ourselves quickly, right? So activity 1 says complete the following table by identifying the different types of equations which have been shown, namely word, picture, or chemical equations, right? So here on the table you have equation and the type of equation, right? And you only need to fill in the type of equation for each of these, right? So I'm going to give you another 4 minutes to complete this activity, then afterwards we shall mark together. Welcome back again, grade 9s. Remember, our WhatsApp number is 079-578-2908, right? Send in your answers, questions, or any comments regarding this lesson. Right. So now we're marking activity 1, right? Complete the following table by identifying the different types of equations which have been shown, namely word, picture, or chemical equations, right? So now, what type of equation is this, right? The first one, it is a picture equation, right? It is a picture equation. Then the second one, it is what? It is a word equation because we used words, right? Carbon dioxide plus water to form glucose and oxygen. Then the third one, it is a chemical equation because we used symbols, right? Then the last one also is a picture equation. So again, I'm going to give you another quick minute to copy down corrections. Welcome back, grade 9s. Now let's continue with our lesson. Now we are entering the topic or subtopic of coefficients and subscripts in chemical equations. Right. So now we see a set of numbers in front and after a chemical formula and so on, right? Those numbers are called coefficients and subscripts, right? So let's look at the differences between the two. So the number that is in front of the chemical formula in the chemical equation, that one is called a coefficient, right? Bear in mind, it is in front of the chemical formula, right? And it is called a coefficient. So the role of these coefficients is to represent the number of individual molecules that are in the chemical reaction, right? So now bear in mind as well, when there is no coefficient or when there is no number in front of a chemical formula, right, it means that just one molecule of that substance will take part in the reaction, right? So let's look at our example here alongside, right? So now I've highlighted coefficients as red, right? So also in the example where you see a red number, that is a coefficient, right? So these twos here are our coefficients, right? They represent what? The number of molecules in this chemical reaction. So now, if you were to look at this chemical equation or reaction, you can see that there is two what? Sodiums on the reactant side, right? And now, on the product side, it means that there is two molecules of sodium iodide, right? Are we together? Now, then there is this number that is what? That is next to a chemical formula, right? Or the number that is called a subscript, right? Which tells us how many atoms of a particular element in one molecule of that compound, right? So these two here that you see on this note marked as blue, it means that there is two atoms of iodine here on this reaction, right? There is two atoms of that element iodine. Are we together? Right. So now it brings us to balanced equations, right? When talking about balanced equations now, this is when we see the use of coefficients more, right? So we're going to talk more about balanced equations. Firstly, what do we mean when we're talking about a balanced equation, right? And before we talk about that, so chemical equations must be written as balanced equation, right? Why? This is because it needs to follow the law of conservation of mass, right? Which states that what you have on the reactant side must be the same in terms of numbers and type of atoms on the product's side. Are we together? So now, the total number and types of atoms of the reactants is the same as in products. That's when we say an equation is balanced, right? When we have the same type of atoms and number of atoms on the reactant side as well as on the product's side. So let's look at this chemical equation here, right? So now, let's note that the white circles are our hydrogen molecules or hydrogen atoms, right? Then the red circles are our oxygen molecules or oxygen atoms. Are we together? So now, I want us to work on this and see if the equation is balanced, right? Based on what I've told you. We say that in order for an equation to be balanced, it needs to have the same number and type of atoms on the reactant side and as well as on the product's side. Are we together? So now let's count together, right? So we have the same chemical equation, right? So I want us to count now the number of hydrogen atoms on the left-hand side and also on the right-hand side, right? So here I'm reminding you again that the white circles are hydrogens, right? So let's count together, right? We're looking only for hydrogens, right? How many hydrogens do we have on the reactants side? Remember that these are our reactants, right? So how many hydrogens do we have on the reactant side? Let's count together. We have 1, 2, 3, 4, right? We have 4 reactants. We have 4 hydrogens on the reactant side. Then on the product side, we need to count again how many hydrogen atoms do we have, right? So we have 1, 2, 3, 4 again, right? So the number of hydrogen atoms balances on the reactant side and on the product's side, right? So now let's get on to the number of oxygens, right? Let's count how many oxygen atoms are on the left-hand side or the reaction side and how many oxygen atoms are on the product's side, right? So we have, remember oxygens is the red circles, right? So we have 1, 2 oxygens on the reactant side and we have 1, 2 oxygens again where on the product's side. Are we together? So now we therefore say that this whole equation is balanced. So now I'm repeating what I said. We say that an equation is balanced when it has the same type and number of atoms on the reactant side and as well as on the product's side, right? So now let's move on again with our lesson. So the following equations are balanced in the following way, right? They must have what? They must have the same type and number of atoms on either side, right? Reactant side and as well as on the product's side, right? So now when looking now at these coefficients that have been put in front of the molecules here, right? Or in front of the chemical equations, these coefficients, they multiply what? The elements in that molecule, right? So we have 4Fe here, right? This 4Fe simply means that 4 multiplied by 1Fe, which gives us 4 what? Fe, right? 4 ions, right? So when looking at the product side now, we have 2Fe2, right? So we have 2 atoms now of what? Of ion or Fe, right? Then now we have put this coefficient 2. So meaning now we're going to multiply the number of atoms of this ion, right? This 2 multiplies this 2 and it gives us 4 ions, right? So these ions balance, right? Then now we have a 3 in front of the molecule of oxygen, right? we have 3 which will multiply the 2 atoms of oxygen and to give us now 6 what? 6 oxygens, right? And when looking at the product side, these 2, remember I said it multiplies the whole molecule, right? So these 2 multiplies the 3 oxygens. Again, we have 6 oxygens, right? So it meaning what? This equation is balanced. Now looking at the following one again, right? We have 2 Mg plus O2 to form 2 MgO, right? So we have 2 magnesiums, right? These 2 on the reactant side, right? We have 2 multiplied by 1 to give us 2 magnesiums plus O2. Then now we have put another coefficient here next to the magnesium oxide, right? So this 2 simply multiplies by 1 again to give us 2 magnesiums, and this 2 again multiplied by 1 oxygen to give us 2 oxygens, and we have O2 on the other side again, right? So this one is balanced as well. Now looking at the third one again, right? It is the same situation. We have 2 coppers on the product on the reactant side. We have 2 coppers on the product side. We have 2 oxygens on the reactant side, and we have 2 oxygens on the product side. Are we together? So now let's quickly move on to activity 2 before we can get on to more examples of balancing these equations. So activity 2 says, study the equation below. Note that the yellow atoms are carbon and the red atoms are oxygen, right? So they will not always necessarily be this color, and note that this is just a representation, right? So yellow, it's carbon, whereas red, it's oxygen, right? Then number 1, what kind of representation is this? Is it a macroscopic representation, submicroscopic, or a symbolic representation? Then number 2, write a symbolic representation or a chemical equation, right, for the above reaction. Then 3, write the formulae for the reactants of this reaction. Then number 4, write the formula for the product of the reaction, right? So I'm going to give you another 4 minutes to complete this activity. Then after that, we shall look into corrections. Welcome back again, grade 9s. Now let's look at the solutions of this activity. Right. So now you needed to tell us what kind of representation is this, right? Is it macroscopic, submicroscopic, or symbolic, right? And that is a submicroscopic representation. Then number 2, write a chemical equation or symbolic representation for the above reaction, right? So the answer is C plus O2 to form CO2, right? Carbon plus oxygen to form carbon dioxide. Then number 3, write the formula for the reactants of this reaction, right? The reactants are carbon plus oxygen, right? Then number 4, write the formula for the product of the reaction, right? And the formula is CO2, right? That is the product. So please take another quick minute so that you can write down corrections quickly. Then after that, we shall continue. Welcome back again, grade 9s. Now let's continue together. Right. So now we're talking about balancing equations, right? So let's look at the rules for balancing these chemical equations, right? So that we understand why do we need to put such a coefficient? Why do we need to do that and that, right? So now, the first rule there, when we balance chemical equations, right, we may only, right, I highlight, we may only add coefficients, right? We may only add coefficients to the chemical formula that are already in the equation. Also, we may not change the chemical formula of any of the reactants or products by changing the subscripts in a formula. So basically in this, we only add coefficients to balance these chemical equations, right? We do not change the subscripts, we do not change the atoms or elements, and we do not change the molecules, right? So we may not add other reactants or products, right? So this includes adding single atoms of any of the elements that are already in the reaction, right? So also we may not remove reactants or products, right? So now let's look at this. We may only add coefficients. That's only what we need to do when balancing chemical equations. So let's look at some word examples, right? So we have what? Na plus I2 to form NaI, right? So why do we say that this one is not balanced, right? We said that a balanced chemical equation needs to have the same number of atoms and type of atoms on either side, right? That is reactant side and product side, right? So now let's look at this. Let's do this so that you understand what I'm talking about, right? So on the reactant side, or in this chemical reaction, we have sodium, right? Na, we have it on the reactant side, and we also have it on the product side, right? We have iodine on the reactant side, and we have iodine on the product side, right? That's why I have NaAI, right? So now, looking at the number of atoms per element here, let's start off by sodium, right? How many sodiums do we have on the reactant side, right? We only have 1, right? Looking at the product side, how many sodiums do we have? We have what? 1 again, right? So the sodiums balance, right? They are the same type and the number of atoms on either side, they balance, right? But looking at iodine now, on the reactant side, we have 2, right? But on the product side, we only have 1. Now we say the equation does not balance because the number of atoms for iodine on either side is not the same, right? We have 2 on the reactants and we have 1 on the products. Are we together? So we can balance this equation by putting these coefficients, right? By putting 2 to the molecule or the product, right? What does this 2 do now? This 2 simply multiplies each and every element in this molecule, right? It multiplies the 1 sodium to give us 2 sodiums, right? Also multiplied by this iodine, it gives us 2 iodines. Now the iodines balance on either side, right? They balance, there are 2 and there are 2, right? From the reactants and the products. Are we together? But now look at this. When looking at the sodiums now, they no longer balance because of what? You have 2 on the product side and you have 1 where? On the reactant side. Hence we put another 2, right? Hence we put another 2 in front of what? Of the sodium on the reactant side so that these 2 can multiply this sodium and to give us 2 sodiums, right? So now this whole equation balances because now we have 2 sodiums on the reactants, 2 sodiums on the products, also 2 iodines and 2 iodines on either side, right? So now I'm going to show you another example, right? So now example number 2, Cu plus O2 to form CuO, right? So also we have what? We have put these coefficients 2, 2, right? So this 2 on the reactant side multiplies the coppers here to give us 2 coppers. And when looking at the product side, we have put another 2 here. This 2 multiplies this copper. We have 2 coppers again. But this 2 on the product side also multiplies the oxygen to give us 2 oxygens. And we have 2 oxygens on the reactant side. Then therefore, this equation now balances, right? So now, example number 3. We have now Zn plus HCl to form ZnCl2 plus H2, right? So now, let us write the information, right? We have zinc, right? We have hydrogen as the elements that are involved. We have chlorine, right? And that one is for the reactant side, right? Then for the product side, we also have the same elements, right? Then we have hydrogen, we have Cl, right? Again, the chlorine, right? Now let's count together. Looking at the reactant side, right? That is this side only. Looking at the reactant side, right? How many zincs do we have, right? We have 1, right? When looking at the product side, again, how many zincs do we have? We have 1, right? So the zincs balance, right? Now looking at the hydrogens now, on the reactant side, how many do we have? We have 1 again. Well, now when looking at the product side, we have 2 hydrogens now. The hydrogens do not balance. So therefore, this chemical equation is not balanced, right? Then how many chlorines do we have on the reactant side? We have 1, right? When looking at the product side, we have 2, right? So you have 2 elements that do not balance on this chemical equation, right? So therefore, how can we balance it, right? This is how, right? We've just simply put a 2, right? And this 2 or this coefficient 2 on the reactant side has changed the whole equation and made it to balance, right? So now, let's do the maths together, right? So now when looking at the, starting off with the zinc, right? When looking at the reactant side, how many? We have 1 and we have 1, they balance, right? Now because we have put these 2 here before hydrogen chloride, what happens? We have these 2 multiplying this hydrogen to give us how many? To give us 2 hydrogens, right? And we have 2 hydrogens on the product side. Now the hydrogens balance. But this 2 also multiplies this chlorine to give us 2 chlorines, right? So it is 2 chlorines and we have 2 on the product side, and the whole equation now balances, right? So can you see how easy it is to balance these chemical equations? Now looking at the last one here, right? We have put the coefficient 4 and 3 and 2 here, right? So this 4 simply multiplies this ion to give us 4 ions. This 2 multiplied by these 2 ions, it gives us 4 ions, the ions balance. This 3 that we have put here multiplies these 2 oxygens to give us 6 oxygens, and this 2 also multiplies these 3 oxygens to give us 6 oxygens, right? Then the whole equation balances again, right? So now, let's quickly look at activity 3, so that after that we can summarize what we have learned for today. So now, activity 3, we have 3 questions, and they simply say, why can we not change the subscripts in the formula of reactants and products when we want to balance an equation? Number 2, write the balanced chemical equation between carbon and oxygen to form carbon dioxide. Then number 3, write the balanced chemical equation between hydrogen and oxygen to form water. So I'm going to give you 3 minutes quickly to complete this activity. Then after that, we shall mark together. Welcome back again, grade 9s. Now let's look at the solutions, right? So number 1, why can we not change the subscripts in the formula of reactants and products when we want to balance an equation? Number 2, write the balanced chemical equation between carbon and oxygen to form carbon dioxide. Number 3, write the balanced chemical equation between hydrogen and oxygen to form water. The answer for number 1 is It is because it will change the formula of the compound, which then represents a different compound and not the one involved in the reaction, right? That's why we cannot change the subscripts in the formula of reactants or products when we want to balance chemical equations. Then number 2, write the balanced equation, right? As we said, the answer is C plus O2 to form CO2, right? It is balanced because there's one carbon, two oxygens, two oxygens, right? Then 3, write the balanced chemical equation between hydrogen and oxygen to form water. And it is 2H2 plus O2 to form 2H2O, right? So now, take the last quick minute to copy down corrections. Then after that, we shall summarize what we have learned for today. Right, grade 9s, welcome back. Now let's summarize what we have learned for today. So today we're talking about chemical reactions, right? So we said that a chemical reaction is the rearrangement of atoms in which one or more compounds are changed into new compounds, right? And we said that all the chemical reactions can be represented by equations and models. Not only that, we said that during a chemical reaction, no atoms are lost or gained, but they are simply rearranged, right? And we said that there are 3 ways in which we can represent chemical equations or chemical reactions, such as submicroscopic representations, macroscopic representations, and also symbolic representations, right? So also we said that, yes, we can use word equations, picture equations, and symbol or chemical equations, right? Also, we said that there are numbers that we usually find in front of chemical formulas, and those numbers are called coefficients, right? Then there are numbers that tell us about how many atoms of a particular element are in one molecule of that compound, right? And those numbers are called the subscripts, right? And we said that there are few rules that you can follow when balancing chemical equations, such as we may only add coefficients to the chemical formula, and we may not change the chemical formula of the reactants or the products by changing the subscripts, right? And also we may not add other reactants or products, and that includes adding single atoms of the element already in the reaction, right? Also, we said that we may not remove any reactant or products. So in the next lesson, we'll be talking about the reactions of metals with oxygen. And now you know the drill, right? Go home, learn more about this topic so that when we come back here, it is easy to learn and teach, right? So now, from me to you now, thank you and goodbye.